Dear students, today we are going to talk about PN junction diode acting as a rectifier. What is rectifier? We need to understand, and we will before we talk about rectifiers, variety of rectifiers, we will recall what is AC and what is DC. Means alternating current and direct current. Well, if it is AC, it means that the two electrodes are having some polarity in the first half cycle, and their polarity reverses in the second half cycle of the flow. It means that say for example we have two electrodes E1 and E2, and one electrode is having positive voltage, means high voltage, and another electrode is having low voltage, means negative voltage. Then what will happen if we connect a load to it? Say we have connected a load to it, then current will start from E1 and flow through the load RL and reach E2. But say this happens for 1 second. Then after 1 second, lapse of one second, after 1 second is completed, the terminal of the electrodes are reversed. It means the terminal E1 is now having high voltage, and terminal E2 is having high voltage, and terminal E1 is having low voltage. And in that case, the current will reverse its direction while it is flowing through the load. And that is shown through a sinusoidal wave, which is showing that the current is flowing in positive direction in the first half cycle. This is the half of the time period in the first half cycle, and in the second half cycle the current is flowing in reverse direction. So that is the nature of AC, alternating current. And in case of DC, say we talk about a simple Leclanche cell or any dry cell, its one electrode is always remaining at high voltage, and another terminal is always another electrode is always remaining at negative low voltage. And therefore if we connect a load to it, then always the flow of current will be from the first terminal E1 towards the second terminal E2 through the load, and that is displayed by this picture, in which we have a certain fixed or nearly fixed voltage applied across the load, always in one direction. Means flow of charge is always unidirectional in case of direct current, and flow of charge is always reversing its direction after each half cycle is in the case of alternating current. Now for the most of the electronic devices we need DC current, and therefore we need to convert AC into DC, and for that we use the diode as a rectifier, means a device which converts AC into DC. Let us see a half wave rectifier. It means that only half part of the wave is rectified and another part is left unused and left unrectified. It means the another part is blocked. Here you see, you must recall that when PN junction diode is forward bias, the current is high, forward current is high, and when it is reverse bias, nearly no currents in terms of microampere. In terms of microampere only current flows through the diode when it is reverse bias. So now let us see, this is a symbol of a transformer. It is connected to some source, alternating source, and that is converting it into the voltage, desired voltage, which is needed by our load, and it could be a step down, it could be a step up, whatever the case may be. Usually it is a step down transformer because we have domestic supply of 220 volt, and in some country it is 110 volt, and usually the electronic devices needs a very few voltage, means 10 volt and approximately like that. So we have converted the AC into the proper voltage range with the help of a transformer, and then when we attach a diode to it as it is shown in the figure, and a load is attached as it is shown here, what happens during the positive half cycle, means for the first half cycle, say we have taken that the upper part is positive, means at higher voltage, and lower part is negative, means at lower voltage. Upper part of the transformer is at high voltage and lower part of the transformer is at low voltage, and in that case what happens, this diode D1 will get forward biased, because on the left of the diode we have high voltage and on the right of the diode we have low voltage, and therefore it conducts, and as it conducts, high current passes through the load as shown by the arrow in the first half cycle. But what happens when the polarity of the electrode reverses? Then in that case the polarity, the upper part becomes goes at low voltage, and lower part of the transformer comes at high voltage, and therefore in this case now diode D1 is reversely biased, because the left side is having lower voltage and the right side is having higher voltage, and therefore the diode is reverse biased. Therefore the current flowing through the load will be negligible, of the order of microampere, and so we can say there is no current flowing through the load. So that means through the load only current flows in the first half cycle, and so the output voltage will be like this. For the first half cycle the current is allowed to pass, and therefore as the voltage fluctuates, the voltage coming out of the diode also fluctuates, but it remains unidirectional for the first half cycle. And for the second half cycle there we get nearly no current, and so we haven't mentioned it. So now after one cycle is completed, again the first half cycle comes, and then we have again the similar current, unidirectional current but highly fluctuating current. So the output will be as if there is very large high voltage here, then for some time no voltage, very high voltage, then for some time no voltage, and like this we get the output voltage. So usually the half wave rectifier are not in use. Now we have full wave rectifier of center tap type. Center tap means we have a transformer having three terminals in the output, and so that the output of the transformer can be divided into two parts. The center tap C, the upper part and the lower part. And so we have connected two diodes with the extreme terminals of the extreme output terminals of the transformer D1 and D2, and a load is connected to the center tap, and the other free ends of the diode are connected to the load. Now what happens during the first half cycle? We have positive voltage on the upper side and negative voltage on the lower side. That means we can take the center to have zero voltage because it is in the center. Therefore the diode D1 will be forward biased, because for the positive half cycle, which is shown by black ink, that upper part is positive and lower part is negative. So the diode, this left end of the diode D1 will have higher voltage, and the right end of the diode will have lower voltage, and therefore diode D1 will conduct. and so some current will start flowing from the diode D1 and reach into the load, move into towards the load, but it will not move towards diode D2. Why this is the case? Because in this case you see diode D2 is reversely biased. In this case you see the bottom part of the transformer is at low voltage, so the left side of the diode is having low voltage and the right side is having some higher voltage. Therefore diode D2 is reversely biased, and as it is reversely biased, it is not conducting, means current is not allowed to flow through it. So during the first half cycle, the first half of the transformer's energy is used, and that energy is converted from AC into DC, and during the second half cycle what happens, which is shown by red ink, that the lower part of the transformer is becoming coming at high voltage, and upper part of the transformer, the output of the transformer, upper part of the output of the transformer comes at low voltage. The lower part of the output of the transformer comes at high voltage, and therefore in this case D2 starts conducting, because left side of the D2 is having high voltage and right side is having low voltage. Therefore D2 starts conducting, and as a result current passes through the load, and no current is passing through diode D1. This is because of the fact that now in this situation diode D1 is reversely biased, because upper part of the output terminal is at lower voltage and the lower part is at higher voltage, so D1 is reversely biased, and therefore no current, D1 is not conducting, and so no current is passing through the D1. Therefore in the second half cycle the lower part of the transformer actively gives the energy, and that is converted, AC is converted into DC. One thing what you can very much observe, that the total energy made available by the transformer is not utilized. Only half portion at a given time is being converted into DC and half portion is blocked. So that means the energy output will be always half of what energy the transformer is making available to the diode. Now we have a better type of full wave rectifier which is usually being used to avoid the wastage of energy. This is called bridge type full wave rectifier. Why we call it bridge type? Because it is having a bridge over here, connected, diagonally connected, two diagonals are connected through the diodes. Now in this case, if we consider for the first half cycle, the upper part is at high voltage and lower part is at lower part of the output of the transformer is at low voltage, then in that case diode D1 gets forward bias. So current starts flowing from the diode D1, it passes through the load RL, and then diode D2 is also forward biased, because some high voltage was there applied across the D1, applied across the RL, and still some residue high voltage was applied on the right face of the diode D2, and therefore D2 is forward biased, and therefore current passing through the RL passes through the D2 and reaches the other terminal of the transformer's output. But at this time, at this moment, during the first half cycle, D4 is reversely biased, because high voltage is at on this left end of the D4, and therefore also D3 is reversely biased because high voltage is on the right end of the diode D3. Therefore D4 and D3 do not conduct as they are reverse biased during the first half cycle. So in this case, current is drawn from the output coil of the transformer and that is allowed to pass through the load RL, and therefore you can see that the full voltage is being utilized. Therefore output should be, if we compare with the center tap transformer and same transformer if we have used here also, then the output voltage must be double of that in the case of center tap type full wave rectifier. Now during the second half cycle, what happens? The upper part becomes negatively charged, low voltage, and lower part becomes high voltage, comes at high voltage, and therefore as a result, now D2 and D1 becomes reversely biased, so they do not conduct, but D3 is forward biased. Now you see during the second half cycle, which is shown by red ink, now the left of the D3 is at high voltage and right of the D3 is at low voltage. So D3 conducts, and then current starts flowing through the D3, moves through the RL, and then it do not go through D2 because D2 is reversely biased. It do not go through D1 because D1 is reversely biased. Now the current moves through the D4 because D4 is also forward bias. Here you see the left end of the D4 is at low voltage and right end is at high voltage. Therefore the current which was released by D3 moves through the load and is allowed to pass through D4. And so what you see that in the second half cycle also, the full energy made available by the transformer was utilized and converted into DC, and therefore the output voltage will be nearly double of that in the case of center tap type full wave rectifier if we use the same transformer in both the cases. So this is all about full wave rectifier. Now still you can see that there are bumps in the voltage output. That means the voltage is very bumpy. It is like this, and that is not desired by any device. It needs a smooth input current, and for that we use a parallel plate capacitor attached to the parallel to the load. So what happens then, when the high voltage is supplied by the rectifier circuit, the capacitor absorbs some of the energy and reduces the peak of the output, and when the output voltage goes down beyond a certain level, the capacitor releases the energy which it has received in the first half cycle. In the first half cycle, so that the voltage is not allowed to fall down very abruptly, and rather it is more smooth. So that way we have a smoother output current and voltage if we use a filter circuit, means if we attach a parallel plate capacitor in parallel to the load, then in that case the output voltage and hence the output current will be more smooth. So that's all for today. Thank you and have a nice day.